Hi everybody, welcome back. Today I'm going to talk about the stomach, and I'm going to talk about it as a complete assembly. I know Gail refers to it as the mid, the top, and the bottom stomach parts. Well, when I started assembly, I decided to treat them as one unit. And I'll show you why as we go through. But as always, I like to start out here on the home page. Give Gail a good reference. It's his project. I enjoy it, and I want him to get good credit for it. So if you go into build your index, you can see exactly what I'm talking about. He has a tutorial for the top stomach, the mid stomach, and the low stomach. The low stomach really is a couple of pieces. Right? Not much to the low stomach. The mid stomach is a good sized project. It involves 2 servos. So does the top stomach. And they're good general references. I went through them. I used them. They gave me some good advice. I downloaded all the parts for that from the STL parts library. Downloaded everything I've got. I'll make what I used available on my download file area. Can't think of the name of it right now. But before we get going, let me explain again. I'm not going to go step by step, piece by piece how to assemble. That's not my style. Plus it's been done, and it's been done very well. So I just recommend that you go to these guys' sites and follow through. I'll put those references. I have them right here. Right, I'll put those references in my comment section so you can get to these videos. Pass through them real quick here. This is Kyle, and he's doing the mid stomach assembly here. He's got some good camera work, some good tips. Again, this is a part 3 of Kyle. He's continuing on the mid stomach. Good work there. And here's Steve. Steve does a little bit of a demo too on the mid stomach, which I enjoyed and learned some things from. But he also did the top stomach, and that was very useful as well. So I would recommend that you go through all of these, study the piece by piece how he did it, listen to their suggestions. I learned a lot, and I think you will too. I learned, especially on this top stomach here, I learned the plastic on plastic squeak and squeal as his robot operated. And I was like him. I really didn't like that sound, so I took some steps that might be beneficial for you to follow through with. Here again, here's Steve again. And this is his top assembly completed. I did exactly what he did. I built it just like this, dry run, no ball bearings, no grease or anything. Just put all the pieces together, test it out, see how it worked. And I would recommend you do the same. Then here, I went back to Kyle. And at this point, Kyle is putting the legs on, which attach to the bottom of the stomach. And in the bottom stomach, there's actually the piece you need to help mount it on the pole, to help mount your robot on the pole. Well, Kyle made a custom piece that I liked, so I elected to use his, and it's available for download from Thingiverse, and I have it referenced in my comments for you too. But this is Kyle's bracket right here, not the iMove site bracket. Just to make clarification for you, this is the bracket I used. So with that said, let me go back here and I'll call up some videos. So there'll be no live demonstration of my robot today. Ralph is out in the garage. He's getting big. Okay, I've got his torso and his belly all put together, or stomach, I should say, all put together, and his neck. He's getting pretty big. Okay, I'm working on the legs, so I'm pressed for where I can work with him. So I took a video and some still shots to show you what I've been doing. Here I started an assembly of the upper stomach, and in Gail's tutorial he points out that you need to set this ring in place before you bring the base up and join it with the sides of the top stomach. Then he says later, if you add the mid stomach, then you go put these screws in to attach the gear coming up from the mid stomach to the top stomach. And then you use these bolts. They sit down in the grooves. You'll see them as you go through their videos, and as we go through my little demo here, I'll point them out to you. There's holes drilled for these bolts to go down in, and they serve two purposes. One is to torque and tighten the ball bearings, and the other is to transfer the torque from the mid stomach to the upper stomach to make him rotate. So you'll see how that all works. That's kind of tight in there. Gail says, oh, just reach in from over here on the side with your wrench and adjust those, And you can just reach in there with your wrench. I didn't think so. That was more than I thought I could handle. I didn't think I wanted to spend that much time. I'd probably end up throwing the wrench or something, trying to turn all that stuff. Plus the fact, well, this screw here is accessible, pretty easily, and perhaps the one in the back is too. How do you get the screws into those sides? I didn't see it. I saw that as a problem. That's why I elected to build this as a complete unit instead of putting on the top, the bottom, and everything. I built it all as one unit. Another problem that I discovered was that if you place these sides down into the notches here, like they're supposed to go, right? These little ends here fit down in the notches. Then you're supposed to come in with your screws, come up through the bottom and screw into this piece, in 4 locations to keep everything as an assembly. Well, building this as a standalone, you could do that. That would mean that you'd have to leave this floating free in here and do it the way Gail suggests. Well, I wasn't going to do it Gail's way, and I couldn't see how to get around this problem. But we worked on it. You'll see. I moved forward on it. But that was the main reason that I treated it as one assembly. I just did the whole stomach as one. This is, I just point this out, this is for me. I'm sometimes slow. There's a left screw and a right screw on that upper stomach, the top stomach part. So as soon as the left screw came off the print table, I got out my magic marker and I marked up that left one. That way there was no confusion. I knew exactly the left screw from the right screw, the mating parts. Just made life simple. So I thought I'd share that with you. Now, I'm going to walk through some stills here of how I assembled it very quickly. I just basically wanted you to see 2 things out of here: how I greased it and how I marked for the placement of the potentiometer. So with that said, let's get started. Here you can see I greased up the trace for the ball bearings, I use steel ball bearings. That definitely will help with the noise because plastic on plastic squeaks. And some of that's the covalent bonding of the plastic atoms. So I greased that up, and of course, then I put on the first side here to the torso, greased it up, flipped Ralph over so that I could insert this piece in, put this spacer in place. Now here you can see from when I did my dry assembly, my potentiometer is fully assembled here. I've got the gear in place, and everything's done and in place. So then once I slid that piece up in place, you can see I just braced it up to hold it in place. And you can see my nasty felt tip work here. I used a red magic marker, and it was too big really to get down the hole nice and clean. But during my dry assembly is when I did all this marking. I went down in here with a felt tip to mark where the gear aligned so that I knew when I was centered when I was doing this point in the assembly. Besides doing that, I also came in this little hole here, caught the tip of one of the gears and a dot onto the spacer assembly. This lines up at the same time this one lines up. That way, once it's assembled, I had a point where I could reference to make sure, yeah, I got it done. I didn't move anything. Everything looks good. So here you can see I took a shot down in there. You can see the glob of red felt tip down in there. Up close look at it. The tooth fits right here between the red glob. This is the magic tooth. If you count out here, you can see I've got the same number of gears on each side, so that's center. So I should have a straight up and down Ralph on my potentiometer. Here you can see with the gear for the potentiometer, you're supposed to align this horizontal, which I've done. And when I did that, then I slid it down into the gear and I marked that tit. So now I knew the tit goes between the heavy markings on my felt tip. Again, reassembled, looking down, you can see I've got my solid red markings in here. Everything's aligned. I have my horizontal potentiometer slot. And I began to grease things. Notice I put grease in here, grease on this face that's going to rub in here. So I've greased it up pretty good. And you'll see in the next slide I actually, the following slide, you'll see it in a minute. On this one, I set my potentiometer in. Once I set it in, I used my hot glue gun and I glued my joints, my solder joints here to keep them separated. And I used a hot glue joint right here to hold the potentiometer in place. I abandoned the idea of trying to use the screws to put all that in place. Here you can see, this is what I'm talking about, where I realized, hey, I got more surfaces than this and this that are going to be rubbing and subject to squeaking. So I added more grease on this surface and on this surface. I lubed it up pretty good, and I also greased this hole. Right, in the bottom one I did as well. Right, where the end plates go on, so that plastic on plastic, because you're going to get a little sag from the weight of the robot, and that top edge is going to want to rub a little bit. So I greased it up to keep plastic off of plastic. And I set my screw pieces in place here, and then I set my second side to the torso. Put it down in place, greased up for the ball bearings, did the same, put the ball bearings in place, greased up the opposite side, and dropped it in. Once I dropped it in, I put my bolt through and tightened it all up where I was happy. And I double checked. My little tit mark and my dot are aligned. So I didn't mess anything up. I got everything in and looks good. It gives me a visible reference point. At that point, I stopped and I was working on my mid-stomach. Now, a couple of things were kind of coming out in the videos and stuff, where on the mid-stomach, it appears that everybody started using taps and started tapping the plastic and using machine screws to do this assembly. Well, I bought some taps, but I sure didn't have good luck. I wasn't getting good threads. So I did the only thing I could do. I went back to wood screws, just to let you know that I had that problem. And all the hole sizes seemed like they were maybe sized for the taps, because they were too big for a 3mm screw and too small for a 4mm screw. So I had to adjust my hole sizes. And while working on it, I snapped that piece off right there. That I was kind of surprised how easy that snapped off. So I would recommend that even though I did a 30% fill, that you kind of treat these with a little love and care. Here I wanted to point out, here's my servos that I'm mounting. And like I said, these holes in the plastic seemed like they were set for machine screws. And when I went back to the same size wood screws that I had been using everywhere else to mount my servos, the plastic split. So I had to come in with my ABS weld pen, I guess I should say, and I had to weld these cracks back up. And I had to do it on all the screws, so that's an area maybe you might want to take a little caution on and think about. Learn from my hardship there. Alright, so here I am. I was thinking about how do I get this ring mounted up in here, right, when I have all this other stuff going on. So, like I said, I started treating it as one assembly. I completely built the mid-stomach, greased it up, put my ball bearings in. Again, I used steel ball bearings. I disassembled my upper stomach to this point. Flipped it over, greased it up, and greased up here where it was going to pass through the hole to reduce all that plastic on plastic squeak and noise. Also notice at this point that I've attached the lower stomach where the legs come on the side, because you have to put the two screws in from the top of the mid stomach. Once you put this piece on, that access goes away. So again, I built it as a unit. I put the mid stomach, the lower stomach onto the mid stomach. Then I didn't have to worry about that. I did dry run all these parts, just like you see in the videos. Before I put all this grease and stuff in, dry run these servo motors, see how everything's working. This picture, this is where I'm supposed to have a picture that showed you how I assembled the mid stomach to the top stomach. But I got so involved in the assembly, I forgot to take the picture. So moving on, this may actually work out to be better than showing you it fully assembled. So I hope it does. So I greased the bottom side of that, as you saw in the slide. And I took this and I mounted it on top of the mid stomach. Then I took this ring and I put it on top of the gear. That allowed me to put these 1, 2, 3, 4 screws in and attach that ring permanently to that gear. And I didn't have to fight it up inside here of the top stomach. Now, as I was telling you earlier, these 4 bolts fit down in those 4 grooves. So now I could just, with finger tight, run those suckers down into the holes. Once they got in, then I could hook power to my servos, and I could run my servos and torque those until I got the desired. I torqued these until I got the desired pressure on my ball bearings. It also let me see, the top plate move. See how everything worked, which worked out great. So now that I had the top stomach plate mounted to the mid stomach plate, I took my servos and I remounted them. So now all this became one assembly. Then I took the mid stomach, the top plate, and the servo gears here, and I screwed them in to the side plates of the top stomach. Now, how that's done is illustrated in the videos that I showed you the reference. Just watch it. It's simple enough. Just basically, you got to turn those gears in opposite directions and they'll screw right in. I did reach down and get control of all my wires, pull them up out of the way so that I knew I didn't have any pinched wires anywhere. And here's a close-up. You can see as I'm screwing in, right, here's the plate. This is already in and assembled, all 4 screws in. All my bolts are adjusted. One thing I didn't do here that I thought about doing, but I got involved and missed it. You might want to put a second bolt, run a bolt up right under that bolt head. Once you get your torque adjusted for these ball bearings down here, then run that nut back down. Just put enough torque to make it squeeze into that plastic a little bit. That would lock that nut so that it can't work loose. Nice to have, I think. I'm not going to tear it apart to put a nut in there. But you can see I'm getting ready to slide my side plates here down into the notches of that plate. I'm still controlling my wires. Once I had everything down in place, you can see here how nice I've got everything flush. Right? My side plates are fully seated down into the base. Now I basically have everything assembled. What I don't have are the screws that would normally come up from underneath this plate into my sides to hold that permanently together. They're not there, right? Because there's no access to them. Before I compensate for that, I stopped and did a test to prove what I thought would work would actually work. So I got out my Uno and my power supply, which isn't shown, and I took the servos from the upper stomach and servos from the mid stomach, and I brought them down. I took my power supply ground and hooked it up to the ground of the Uno to keep my voltage reference points constant. I took digital out 3 and I hooked it up to the mid stomach. I'm into the upper stomach. Digital out 4 and I hooked it up to the mid stomach. And I did my test. And here's the video of what I did. Now it's a little bit shaky. My wife was holding the camera for me, actually my telephone, while I ran my robot lab and actually made things happen. So let's see how it worked. First you'll see these screws move. Remember, he's laying on his chest, so he's moving side to side instead of tilting like this. Okay, he's running back and forth real nice. Now I'll move the mid stomach, make him rotate like this. I have my video recording my speakers, so I hope you can hear the amount of noise. You can hear the servo motors, but I really didn't hear any squeak and crack of the plastic moving on anything. So I think all my grease points gonna help that noise. Now let's see how I did that with my robot lab. As usual, I did my normal startup. You can watch my earlier videos, the bicep and so forth, to see how I got my robot lab up and running. So I'm going to shorten this video and skip all that setup stage. But I did go into intro. I hit my little fingerprint and I started up my robot lab. And once I did, I got here, I did my lazy startup, started everything up, and that filled in all my objects over here on my menu. And then for my convenience, I killed his ears and I killed his mouth, and I don't get that feedback from him, listening to me and trying to respond. I haven't done anything with that, so it's random what he does. So I just turned him off. Once I did all that, then I went to torso. Over here, right on the menu, went to torso. And that gave me the top stomach and the mid stomach on one page. So if we go to the top stomach, went to the controller. I did set up a controller. I didn't show you that step. But I set it up on the right. I'm not sure if it's controlled from the right or the left when it's properly wired. But for test purposes and me using pins 3 and 4, it really doesn't matter. I chose the right controller. Set it up. Set it on pin 3 for the top stomach. Then I went to my limits. 90 degrees is the center point, where he's straight up and down. And for testing, I always limit very tightly the movement. So here I gave him 15 degrees of movement each direction. Once I get him on the pole and get a little weight on him and his arms and everything on him, I'll adjust that, how much I allow him to lean in each direction. But for these test videos that you saw, I set him to a 15 degree movement in each direction. And then I went to basic and I used my slider and I just slid him back and forth, as you've seen me do in the other videos. I went to mid stomach, and here on mid stomach on the right controller I selected pin 4. Then I went to my limits, and again I restricted the movement to 15 degrees in each direction, so you can see it move. Just a quick test. I went to basic, and then I used my slider back and forth to move him back and forth. Everything worked great. Nice simple way of getting it all done. So that's the depth of what I'm going to go into here on my robot lab. Hey guys, You may notice a little jitter in this video. I finished the video, did my review, and realized I left a step completely out, and kind of an important one. So I've come back and done this little insert so you could catch that step, because it's an important one. So I showed you how I assembled it all together, and I showed you my little video on how everything moved. I showed you how I used my robot lab to do all that testing. Once it was confirmed, I needed to make sure that these parts are going to stay together, because those 4 screws are not there anymore. So let me show you what I did. Blow this up real good. I showed you earlier how I had everything sitting down in here nice and flush. Well, now if you look real close, you can see that I've laid in an ABS weld, and I actually welded this piece to the base. So no screws, but it's permanently attached, and I think it's going to work. If I have a problem, these may have to become sacrificial pieces where I cut them out, but they're a whole lot quicker to print than this base. So that was my solution. I welded it. I just abandoned those 4 screws and put a weld in. Of course, I did it as many places as I could to make sure it was strong. So that was my solution. Let's get back to what I had already recorded on the rest of the video. Now, once I had finished that little test and showed you the servos work, I flipped him over. In the oil field, when we hang accessories onto a drill line, we called it jewelry. So I hung his jewelry, and I put the NeoPixel in place. But before I put this little faceplate on here, I did put the pole attachment in, and I'm getting ready to talk about that. But this is what he looked like when I flipped him over and hung his jewelry on him. Started getting him prettied up, all gussied up. So let's talk about that bottom stomach assembly. As I said, I didn't use this pole attachment that came from Gail's download. I used the custom one off of Universe, or thingiverse, I guess it's called. Okay. Now, I liked it, and I thought it had its benefits, so I went with it. I guess everything he did was metric. If I remember right, he's in Australia. So I ran up to my local Home Depot and bought my little steel L brackets. And since I was there, I went ahead and bought 832 machine screws to fit. Everything else on my robot is metric. But I went ahead and broke down and got 832 screws and nuts and lock washers. They fit the holes nicely. But these are English measurement brackets, and they weren't the same length as his brackets. So they didn't fit as nice as his. So I had to do a little work. I think you'll find this is a heavy custom area for you as well. So when I put them in, I had a gap between here and the bottom stomach pieces for holding the legs. So I had to get some wood out, or pressed fiber board, I guess it was, and I cut some spacers to go in here. This is all custom. And I had to drill in, and you get the angles and everything's off, so some of the holes are a little bit oversized to give me some slop to play with. But I did use lock washers, star-styled lock washers in here. The next picture will probably show them better. Yeah, you can see I've got the star lock washers in there. So once I put that screw through and tighten it down, they're not coming loose. These were 3/4 inch length screws. These were 1.25 inch length screws. 8/32 is what I used, but your size may vary. Now, interesting, the gap for this fiberboard on this side was different than the gap on this side, just where the hole placements worked out. So I got out my file and I had to file my board and, get everything to fit. Like I said, this is all real custom work. But I got that. Now I've got my stand and I'm starting my leg. I need to get at least one leg built before I can get my pole length determined. So I've gone through a lot, went through it pretty quick, pretty high level, just an overview of what I saw, the way I solved the problem. You might want to use it, you might not. Maybe you've got a better method. If you do, share it, make a video, put it out there for everybody. With that all said, I hope it's helpful. I hope it gives you at least a thought pattern, help you find your solution. My stomach's all done, hooked to the torso. It works like a champ. Wish you guys well with your assembly. I'll catch you again next time. Thank you.